Chapter 11.2, Day 1, we're looking at vectors in space. We're going to find the component forms of the unit vectors in the same direction of, the magnitudes of, the dot products of, and the angles between vectors in space. We're going to determine whether vectors in space are orthogonal or parallel, and we're going to use vectors in space to solve real-life problems. So vectors in space, physical forces and velocities are not confined to the plane, so it is natural to extend the concept of vectors from a two-dimensional plane to three-dimensional space. In space, vectors are denoted by ordered triples. So we see this here, and this is the component form. Note that the zero vector is denoted by 0, which is 0, 0, 0. And then using the unit vectors, I equals 1, 0, 0, j equals 0, 1, 0, and k equals 0, 0, 1. The standard unit vector notation for v is v sub 1 I plus v sub 2 times j plus v sub 3 times k. When v is represented by the directed line segment from point P to point Q, so here, point P to point Q, notice the initial point is P and the terminal side is Q, or terminal point is Q, you find the component form by subtracting the coordinates of the initial point from the corresponding coordinates of the terminal point. So notice, to find the vector, you're taking the terminal point Q and then Q sub 1 minus P sub 1, and then Q sub 2 minus P sub 2, Q sub 3 minus P sub 3. So notice that, how it's being subtracted there. So here's some important formulas that you probably want to have. So two vectors are equal if and only if their corresponding components are equal. The magnitude or length of u is the square root of u sub 1 squared plus u sub 2 squared plus u sub 3 squared. A unit vector u in the direction of v, u equals v over the magnitude of v, and of course v cannot be 0. The sum of u is u1 plus v sub 1, and then u sub 2 plus v sub 2, and then u sub 3 plus v sub 3, so vector addition. The scalar multiple of the real number c and u, so notice that we just multiply to each point there. And the dot product of u, so notice that you're going to multiply and then add them. So this is u sub 1 v1 plus u sub 2 times v2 plus u sub 3 times v sub 3. So let's first find the component form of a vector. Find the component form and magnitude of the vector v that has initial point 3, 4, and 2, and terminal point 3, 6, and 4. Then we're going to find a unit vector in the direction of v. So remember that we're taking the terminal point, we're subtracting the initial point from the terminal point. And so we know, let's just call this P here and call this Q. And so this is going to be Q is 3 minus P, and then 6 minus 4, and then 4 minus 2. So this is 0, 2, and 2. So this is the component form. Now let's find magnitude, right? We're looking for a couple of things. So the magnitude of v, that is the square root of these values here. So it's the square root of 0 squared plus 2 squared plus 2 squared. And so that equals the square root of 4 plus 4, which is the square root of 8, or 2 root 2. And so that is the magnitude of v. And then this is just our v here. Now to find the unit vector in the direction of v, we're going to take v over the magnitude of v. So we have 0, 2, and 2, and the magnitude is 2 root 2. And then we could rewrite it in this way. So 1 over 2 root 2 times 0 times 2 times 2. And so let's separate it out. This becomes 0, and then 2 over 2 root 2, and then 2 over 2 root 2. And so we can cancel that out. This is now 0, 1 over root 2, and then 1 over root 2, or this is 0, root 2 over 2, root 2 over 2. And so that is the unit vector in the direction of v. So go ahead and try the example down here. Find the component form, the magnitude of the vector v that has initial point of 1, negative 4, 3, and terminal point 2, 2, negative 1. Then find a unit vector in the direction of v. Okay, if you tried this out, you should have gotten 1, 6, and negative 4 here. The magnitude is square root of 43. And then so you found that the unit vector is square root of 53 over 53, 6 root 53 over 53, and negative 4 root 53 over 53. Next, let's find the dot product of two vectors. So we have find the dot product of 0, 3, negative 2, and 4, negative 2, and 3. So we're just multiplying these together. And so what we're taking is this is going to be 0 times 4 plus 3 times negative 2 plus negative 2 times 3. So this ends up being 0 minus 6, or negative 12. So I'll go ahead and try this next example below. So here you should have gotten negative 2. Next, let's find the angle between two vectors. If theta is the angle between two non-zero vectors u and v, then we're going to use cosine of theta equals u times v over the magnitude of u times the magnitude of v. So let's do that. So we have cosine of theta equals u times v. So this is going to be 102 times 310 all over the magnitude of u. So that's the square root of 1 squared plus 0 squared plus 2 squared. And then you're going to multiply that to the square root of 3 squared plus 1 squared plus 0 squared. And so you would get, for the numerator, 1 times 3 plus 0 times 1 plus 2 times 0 all over the square root of 5 times the square root of 10. And so now we're looking at the cosine of theta equals 3 over, we have 5 times root 10, so that is going to be 5 root 2. And we could rationalize the denominator, but not quite necessary since we're just plugging into the calculator. But this would be 3 root 2 over 5 times 2, which is 10. So we're trying to find the angle. So then we're going to do theta equals cosine inverse of 3 root 2 over 10. So plug it in your calculator. You do want degrees here, so make sure it is in degree mode. And when you plug it in, you get 64.9 degrees. So go ahead and try this example. Find the angle theta between u and v. All right, if you tried this out, you would have gotten cosine theta equals 4 over 7 root 6. And then when you plug it in your calculator, you should get theta as approximately 76.5 degrees.